The fifth question that we have can be very simple. If you know the determinant method to solve the question, we have to prove that these two lines are coplanar and we need to find out the equation of the plane in which they lie. So for these two lines to be coplanar, they can either be intersecting or they can be parallel. Only in these two cases will they be coplanar. Now let us take the first case in which these two are coplanar. This line passes through the point a minus d, a plus d, and the second line passes through the point b minus c, b plus c. You can check this out by putting these 2 points over here. This is actually nothing else but x minus x2, that is b minus c. That is how I have written x2 over here. Now let this point be p1 and this point be p2. We have a point p1 over here and a point p2 over here, and we have the direction ratios of this line given to be alpha minus delta alpha and alpha plus delta. Therefore let this constitute the vector alpha minus delta alpha, alpha plus delta, and this one constitute the vector, the direction ratios of the second line, beta minus gamma, beta and beta plus gamma. Now these two are the two vectors in the direction in which the line lies. Therefore we have a line passing through P1 in the direction of vector V1. Let me call this V1 vector and this one equal to V2 vector. Therefore this is V1 vector, and we have another line in the direction of V2 vector. Now we are taking the case of these two lines are intersecting. So if these two lines are intersecting, then the vectors P2 minus P1, this vector is P1 minus P2. P1 vector is the position vector of point P1, that is this one is P1 vector. This is P2 vector, that is the position vector of point P2. P1 vector minus P2 vector will give me the vector joining P2 to P1. Now we can clearly see that since this vector is V1, the vector representing this side of the triangle will be some A into V1 and this will be some B into V2, the vector representing this side of the triangle. Now since these three vectors form a triangle, they are coplanar. Therefore we will apply the condition for these three vectors to be coplanar, that is we write the AV1, the determinant formed by AV1, BV2 and P1 minus P2, the determinant formed by the x components, y components and z components of these three vectors will be equal to 0. We can remove A and B because if they are 0 it doesn't matter if we write A and B or not. Therefore applying the same logic we can write over here. Let us write first P1 vector minus P2 vector, that is A plus D, A minus D minus B minus C, that is A minus D plus we have to minus this thing, therefore it becomes minus B plus C. The second point, this y coordinate becomes A minus B, the z coordinate becomes A plus D minus B minus C. For the second part we have to write the direction cosines, that is alpha minus delta, alpha, alpha plus delta, and for this one we will write beta minus gamma, beta into beta plus gamma. Now we see that if these two lines are parallel, then also the result has been incorporated into this single determinant, because if these two are parallel, this row will be a multiple of this row and the determinant will be 0. So in that case also we get the result. Therefore applying this thing is sufficient. Therefore we see here that if we do the transformation, C1 goes to C1 plus C3, that is we add these two columns, then we get 2 times A minus B over here, we get 2 times alpha over here and 2 times beta over here. Now we can multiply this column by 2 and then subtract both of these to get the value of the determinant to be equal to 0. Therefore we are getting the value of this determinant to be equal to 0. Therefore we can now say that these two lines are coplanar. Therefore we have already proved that the two lines are coplanar by using the determinant method. Now we need to find out the equation of the plane. Now, therefore we need to find out the locus of the point which moves such that it is lying on this plane. So any point h, k, l lying on this plane, the vector joining this point to any of these points P1 and P2, this vector and the P1 vector and P2 vector will be lying in the same plane. Therefore we can write h minus a plus d, k minus a, l minus a minus d, and again these two things alpha minus delta, alpha plus delta, beta minus gamma, beta and beta plus gamma, this to be equal to 0. Now, therefore what we had got is that h minus a plus d, alpha minus delta, beta minus gamma, k minus b, alpha beta, and here we get l minus a minus d, alpha plus delta, beta plus gamma is equal to 0. Now this is a relation solely in terms of h, k and l. Therefore we can replace l by z, we can replace k by y and h by x. Now we have to solve this to get the final relation in x, y and z. Now let us do a transformation over here. C1 goes to C1 plus C3 minus 2 times C2. On doing this transformation we get x, we get C1 plus C3 minus 2 C2, that is x plus z minus 2y, we get 0 and 0 over here. The other two columns do not change. This is y minus b, alpha into beta, this is z minus a minus d into alpha plus delta, beta plus gamma, this is equal to 0. Now on solving this we get x plus z minus 2y into alpha times beta plus gamma minus beta times alpha plus delta, this is equal to 0. Now this is not equal to 0, therefore this is equal to 0, that is x plus z minus 2y equal to 0. Therefore we get the equation of the plane as x plus z minus 2y is equal to 0, and this is a final answer for the equation of the plane in which these two lines lie. So finally I'd just like to say that remember this determinant method, in which you do not need to understand this or remember this also. Just remember the determinant method, that if two lines are coplanar, then the points, write down the points here, x2 minus x1, y2 minus y1, z2 minus z1, this is equal to z2 minus z1, y2 minus y1, x2 minus x1, and the direction ratios, that is alpha minus delta, alpha plus delta, and beta minus gamma, beta and beta plus gamma, this will be equal to 0 for this question. Now if you want to find out the equation of the plane, then what you do is that you write x minus any one of the points, choose any one of the points. You could have done this also or this also. Let us do it for the first one, x minus a plus d, y minus a, z minus a minus d, and again write down these terms over here to get alpha minus delta, alpha plus delta, and beta minus gamma, beta plus gamma is equal to 0. So this is how you find out the equation of the plane, and this is how you prove that two lines are coplanar. So the final answer that we got was equal to x plus z minus 2y is equal to 0, and this is our final answer.